This is video 9 in the Standard Library Fixed Objects module, and in this video we'll talk about resources. In particular, we'll talk about the resource object in the Standard Library, and then we'll also revisit the concept of smart resources, which we've talked a little bit about in the context of the server object and the combiner and separator object, which all three have internal resource objects, and so they have the same behavior and same characteristics that we'll see in the resource object itself. So the resource object is, again, an object in the standard library, and it provides a generic object that you can use to constrain entity flow. So it doesn't permit flow itself directly through an object, but it can be seized and released, and we can use this seizing and releasing to maintain capacity constraints. It also incorporates reliability, failures, and we can collect usage statistics on processing data. So let's look at a quick example here of how we might use that. We might use a resource object. So what I'm going to do is I'm just going to place a source server sync right here. Let's see, source server sync, and then I'm going to place another source server sync immediately below it. So source server sync and source server sync. And then I'm going to connect these all up with path. So path from source to the server, path from the server to the sync, path from the source 2 to server 2, path from server 2 to its corresponding sync. So what we have here is two independent single server systems. And so if we run this model, we can see we haven't changed any of the properties, so we're just using the standard default properties for all of the objects. And so you can see the sources are creating entities that are going to the servers and so on. And what we have are two completely independent systems. Now, suppose that what I'm modeling are let's say two manufacturing processes. Server 1 is a machine and server 2 is a machine. But suppose that in addition to the server, I also had to have an operator. So in other words, I want to make sure somehow that only server 1 or server 2 is busy at any point in time, right? So I'm creating a dependence between these two. Well, I can do that easily with a resource object. So I'm just going to place a resource object here in the middle. So I'm going to just leave it at resource 1. And then I'm going to go in server 1 and go to the secondary resources and say the secondary resource for processing that I need is resource 1. And then I'm going to do the same thing at server 2. And so now I'm going to go to server 2, secondary resources, object name, resource 1. And so now when I run, we're going to see that the entities start backing up at both servers. So we see entities start backing up at server 2, and in a second we're going to see entities start backing up at server 1. And the reason we're seeing that backup is now only one of the two can be processing it at any one time. So in addition to the server, you also need the resource. And if we look at the default characteristics, we have entities who have an inter-arrival time of 0.25 minutes and processing times that are 0.2 minutes. And so if one source is producing entities for one server, you can keep up. But in this case, since we require the resource, we can't keep up anymore, and so that's why we're seeing that. That's why we're seeing that backup. And so what we're using the source here is we're using the source to constrain entity flow. So we're having two conditions: capacity at the server and the resource. And so of course, if I went into resource 1 and said, okay, well, let's give it capacity 2, right? Let's give it capacity 2. Now I'm back to the system that we had before where they can operate completely independently because I only have two servers. I have two units of resource 1 capacity available. So the example that we just saw was for a stationary worker, but we can also use the exact same technique to model fixtures. So maybe I have two machines and they share a fixture. It would be the exact same implementation. We can also use it to model floor space, and so basically any situation where I want to constrain entity flow, I can use a resource where I have to seize or release that resource. And in our example model, that's exactly what happened when we specified a secondary resource. Is in order to start the processing, the server is going to try to seize that resource, and when it finishes processing, it's going to release it. And so we're using that seize, delay, release logic internally to the server object. And it turns out that using the resource object is extremely useful in situations where I need to be able to constrain entity flow, but I don't actually have entities flowing through an object. I just want to constrain their flow elsewhere in the model. And that brings us to the notion of smart resources. As I mentioned earlier, the resource object is component in the server object, the combiner and separator objects, and so all of those objects inherit this behavior. And that behavior is smart in the sense that we can incorporate things like static ranking and selection that we saw that let us prioritize the queuing. We can use work schedules and incorporate exceptions, so you can incorporate vacation days and so on, and so you have that same seize delay release logic but over a work schedule. We can do dynamic ranking selection where we actually look at all of the entities in the queue. We've seen examples of this when we talked about the server. And finally, we can evaluate the seize request through an add-on process. And so we can actually reject seize requests. So think of a situation where a resource is available, maybe you're modeling a worker, but that worker only has 15 minutes remaining in their shift. Then you can simply use the add-on process to reject the seize request. And so by smart resource in a typical seize delay release environment, if the resource is available, the seize will actually grant access to that resource. But because the Simio resource object incorporates this ability to reject seize requests, we can implement much more complex behavior. And so as we've seen, the resource object, and consequently those objects that are built upon the resource object, are extremely powerful. And using this behavior, we can implement virtually any type of resource logic in a very straightforward manner. And since all of these objects are based on the same resource object, the behavior is the same across the entire family of objects. And that concludes this video on resources and smart resources.